Okay, so let's enter the developer's playground and start talking technical. This is where we'll build an open source decentralized app on aeternity blockchain. The workshop session would be anchored by Jesulonimi Akingbesote. I'm sorry, I've been practicing that surname for a while now. I still don't get it. Akingbesote. I think that's it. Jesulonimi is a software developer that builds awesome solution using React, Kotlin, and aeternity tools. He's aekiti, aembassy co-lead, and has written aeternity web and mobile-based tutorials to help developers in the aeternity ecosystem. With Jesulonimi, you will learn how to build an app on aeternity blockchain. Jesulonimi, you have the floor now. Minato, your mic is off.
Sorry about that. Yeah. Thank you. So my name is Jesulonimi, and I'll be helping you build a centralized application using the Eternity blockchain. We'll just walk you through building a small application or a small smart contract I've been making of recent. It's like an online lottery application actually. And yeah, I hope it will be fun building with you. So let me share my screen with you now. Okay. Okay, Opera tab. And yeah, good. Yeah. So so I'll be doing this using A Studio, and as you can see, this is like the first screen you see when you're on A Studio. You see this particular example. It's called the crypto hamster example, and yeah. So for my own example that I'll be showing you, I'll just create a new tab by clicking on this plus button, and it's important you take note of this URL. It's https://studio.apes.com. I know previously this to be file editor.nikitafoods.de, but I think I had out this and that has changed, and probably it's now this one. I don't really know what's the difference between the two actually, and I had that you need to access on HTTPS and not HTTP, so you can take note of that while joining me. That's if you decide to. Yeah, good. So first thing I'll do is I'll read the code in this particular tab here, and my tutorial is going to be an online lottery application. So how this is going to work is going to be that a person will be allowed to wager on a particular number. Then when he wagers on this particular number, he will also be asked to select a particular amount that is wagering on the number. Then a lot of people will actually participate in this. We'll call them contestants. And after this, we can run a particular function, which you guys will see to call the announcement winners. It would actually list the people who have won the contract based on a particular random number, which will match and check if it's equal to the wagering number of any one of the people who are or the contestants for this particular application. For this particular application, we'll be using a particular library, which is the list library. So that's the first thing I'll do here. I'll just write include. Include this.is. Yes, good. So these are you include the list library. Then after this, the next thing you need to do is actually write your contract name. So I'll say contract, and I will name it lottery. All right, yeah, good. So what we've just done here in these two lines of code is that we've actually included the list library in our application or in our smart contract, and we'll specify that it's going to have a name, and we're going to call it lottery actually. So yeah, I'll do this. Then we need to define a particular record for our contestants. If you are coming from a mainstream language, you can think of a record as an object or something similar. Probably you are coming from JavaScript, you can think of a record as an object. It has fields or keys and they have values, so something like that. So we can say, so we'll say contestants. Sorry, yes, is equal to, yeah. Then we'll specify that each of our contestants should have a user which will specify the address, a number, and a value actually. So do that now. Just make sure you write the word record there. This URL. that specifies that it's a record actually. Then we're going to have a user field now, a user key, and this will be of type address. So this is how we'll be able to actually pay whoever wins the contest or whoever wins the lottery itself. Then there will be a number. Then this is going to be of an integer type. Then we need to say the amount they have actually put in the contract. Amount, hold on. Yeah, good. So we have this now. So basically what this means is that now I can have several contestants, and if each contestant would actually have an address, they will have a particular number they are wagering on, and they will also have the amount they are putting on that particular wager. So good. So the next thing we can have here now is our state. So our state represents what our application looks like at the initial deployment of it. So apparently our state is also going to be a record soon. So I'll say record, then state. Then the next thing we'll actually be doing is declaring our state values, our state type. So first of all, we're going to have a winning number, and this number, this is just so that we can see whatever the winning number is actually. And it's going to be of type int, good. Then we are going to have a list of contestants. So I'll say list underscore of underscore contestants. And it's going to be of types lists, then contestants. That's not good. Then we are also going to have a minimum wager, that is the minimum amount that anybody can cast as a wager itself. So I'll say MINIMUN. That's called JG. Good. Then it's going to actually be of typing. So if let's say our minimum wager now is probably 1 token per se, or probably 1 times 10 power 18 ATOs, then can a person actually specify that's going to actually spray and give 0.58 token, will just actually abort the application and tell him that, yeah, whatever amount is putting in must be greater than or equal to the minimum wager. Great. So we can actually proceed. Now the next thing is the number of wagers, like number of people where this contract is actually expecting. So I would say now make sure there's a comma here. And it's going to actually be of type int too. Good. So yeah, so this will specify total number of people or total number of contestants in our application. And by this we can actually calculate the time that we have specified that will actually announce the winner, the time for which the contestant's winner or the contest winner itself will actually be called out or selected, or will pay money to that particular contestant's address. You can think of it like that. So if let's say we have specified here now, we should specify in our init function that there are going to be 3 people who would actually cast the wager. When the person casts the wager, we can answer that okay, it's probably the first person that actually won the lottery or something like that. Yeah, good. So yeah, so we'll come back to this state as we build on it. We'll come back to the state and decide if let's say we need to add something new to our state. So the next thing I would actually add is our init function. So I'll say entry point. It's good. Is equal to this. So our init function basically returns the initial value of our state deployment. So I can say win underscore number is equal to, let's say it's equal to 0 now. We'll actually change this during program execution. And I can say list underscore contestants is equal to an empty list. Then I can say the minimum wager. Let's make that equal to let's make that equal to 1 A token now, and that's because it's actually in ATOs, we need to multiply by 10 to the power 18. So yeah, good. So now the number of people we're expecting to cast the wager in this contract, let's say they're just to let's make it actually small so it's easier to test actually. Good. Now the next thing we'll do in our contract now is to actually make sure this is actually like this, because Sophia is actually it's indentation based actually, so make sure you indent properly. Good. So I forgot init function, endpoint in here. Good. So this actually returns the state. So next thing we'll do now is we'll add a particular function. We're going to be an entry point now. I'll call it bet now. And this particular function will take in a number. number will be of integer type. Good. So now the first thing I want to check now is if this number, if it is equal to the minimum wage. Sorry, if this number, okay, we also forgot something here. This would be the minimum underscore, sorry, the maximum number that a person can cast away down. So that our whole contract is actually making sense. So, because if let's say we specify that the maximum number should be 1,000, for instance, that's going to be very, very difficult to get, because the person can say the number I'm casting away down is 1, 2, and that's up to 1,000. That's about 999, which is not fair. So let's make sure there's a maximum number. Let it be something small. If we're only expecting 2 people in our contract, I think it will make sense for us to actually make the maximum number something small, probably just 4 thereabouts. Yeah, good. So, but because of that, we also need to actually add it right here too. So, good. Now can come in now. Okay. Oh, sorry. There's a slight error here. I know I made that to be here. So record state is equal to this, then list of contestants. I know I made this error. This should be able to see. Yeah, good. So we click on this one. This okay, good. So now, right, I'm going to check if the number I've entered, if it's greater than or equal to number. If it's less than, if it's greater than or greater than our state but maximum underscore number. This should be an X. It should be an X here. Good. So that's a typo. Right here too. Great. So maximum underscore number. If this is the case, then we want to just abort. And let's abort the message. Let's say your number. Sorry. Must be less than our maximum number here was 4. Good. Less than 4. Good. So if that's the case, then next thing now is I'm going to actually say, if let's say this is the case, that is the number I have actually put is at least, if it's greater than Amazon number, our option will actually abort and not allow him to continue. Now if let's say it is less than that particular number, option will allow him to continue. We need to decide what we actually want to happen next. Now we also want to actually check to if the particular amount that the person has specified is greater than or equal to our minimum wager here. So let's say the amount I said we will wager on. Okay, so yeah. So I would say require. Now let me use the require. So there are several ways you can actually do this now. But a particular way is for you to use the require. Require is a function that takes in a condition, and if that condition is actually true, it's just abort. So what we want to actually check now is if call.caller is less than state. Sorry. Okay. That's minimum underscore wager. Then specify a string and say you must put at least it token in the contract. Good. The contract. So yeah, great. So now it seems like I'm getting an error here. Okay, sorry. This is due to indentation now, so you can see, yeah, good. So this will also be an equal to sign here. Good. So great. State dot minimum underscore wager. Then yeah, we'll do this. Then the next now is for us now. So if let's say this is the case and call.caller is not less than the minimum underscore wager, what would actually happen is you actually allow the column execution to continue. Sorry. Then if let's say this case, we can now create a contestant object now, a contestant record now. So as a contestant is equal to, yeah, then I would say, let's look at what we have here again. We have a user, a number. Sorry, this should be called dot value. Called dot value is actually the amount passed in. So say user equal to call dot caller, then comma, let's see what we have here again. Number is equal to number, this one here. Yeah, good. So let me just come here. Good. Then lastly, we need something else, the amount. Good. Then amount is equal to call dot value. Great. So just created the contestant record now from data we have so far. Now let me just state some things actually. Call dot value is the amount passed into the contract by the user. So for us to actually pass a contract, if let's say a particular function receives money in, it is to be payable actually. So but this particular function is also going to actually change our state too, so it needs to be stateful too. So but because it's going to actually receive money and it's going to actually pay out money, so as this is like default entry point of our application. This function is going to be a function that will call all nearly all functions, including the function that will decide if a person actually gets the lottery or not. So it's going to actually be created as payable soon. So payable entry point. Good. So great. So now make sure there's a comma here too. So one thing about STUDIO is it actually warns you of errors using all these. You can see this red line here, and actually presently I'll need to actually refresh now because this should not be the right error. Yeah, okay, this should be the right error. Yeah, great. So thing is that we need to actually continue because you cannot just declare a value and not use it to keep on warning you about the let constant. So what we need to do now is get the current contestant list from here. Okay, so we'll do this now. So and we'll now add this contestant to the new contestant list. So now we'll say let's new underscore lists underscore of underscore contestants is equal to. Now, the thing about Sophia is in most other particular programming languages, mainstream programming language like probably Java, you use things like push, so probably add an element to a list or to an array or something. But in Sophia, it is like dispute like this, just the element you want to add first of all, then two particular quotation, two particular colons, then the list, the new list that you're adding things to. So that will now be our state dot list list underscore underscore. So what will happen is that it will not mutate this particular list. What we'll actually do is that we add some items to this particular list and actually return it, so we'll actually be able to access it here. So yeah, great. So that thing that will be good for us to actually save. Okay, we will specify that here. The total number of wages. We need to actually save the amount of wages at each time in the contract. That is the amount of contestants at each time in the contract. So we might have to actually store that in our state actually. So let's just come here. So and let's say present number of contestants underscore contestants, and let's say it's going to be of type int. Great. Then make sure to put a comma here, and let's come here again and say let's copy it. At initial stage one with the press going to actually be equal to 0 since there's no contestant yet. Great. So yeah, so done this. So now what we need to do is let's new new underscore num underscore of underscore contestants and okay, let the number of contestants equal to state dot present number of contestants plus 1. Great. So if it's actually not now, next thing we need to do is actually save these two values in states. So great. So put state Then we can specify and say list underscore contestants is equal to new underscore list underscore contestants. Then we can also check now and say, okay, new number of contestants. So we need to update that to present number of contestants. Sorry, present number of contestants is equal to new underscore norm underscore contestants. Great. So what we basically do in this particular function is, number one, we check if the number entered is greater than the maximum number, which is the maximum we have to specify here. Now specify that it's going to be actually be 4 here. So we abort if that's the case. Lastly, we require that the color value is less than we check if the color value is less than the state of minimum wage, which is what we have here too. So if it should be 1A token actually, then we abort with this particular message too. And also there are some other things that we might actually want to check, and I think we should actually check that too because of our time. Let's check that. So one, I want to check if a contestant actually exists. So let me use that check it underscore, because we don't want someone to be able to actually contest twice or place a wager twice. So sorry. Contestants. Let's go on. Sorry, all of that. Wow, seriously? Okay, yeah, great. Oh, sorry, I mistakenly left this particular page. Exists. Great. So, and let's create this function. So, yeah. Good. So, good. So let's create. Let's say function. And yeah, is equal to switch list. Now this way I begin to use list library. We actually imported it right here. Sorry, this is here. We did list library here. So where I begin to actually use it. So let list.find. So the first argument we'll actually receive is going to actually be a particular predicate now, or a particular condition, and the next element will actually be the list itself. So that will be list.find. So predicate will be, let's say A is equal to a.user equals call.caller. So what we actually just check is actually the public address. So we check if, let's say, this user ID existence, each user is actually contestant. We check the public address, actually user clone address. If, let's say, it's equal to the call.caller, which is the person actually calling the address for the contract presently, calling that particular function in the contract presently. So if, then lastly, we need to also specify the particular list. So that will be state dot list underscore contestants. Then yeah, so next thing we do here is none. I've mentioned there is none, just return false. FALSE. Let's say there is sum of x. If there is some, return true. Great. So that's for that particular function. So wait, we don't need this here. So it will actually check this particular case. So right here, we might want to put this in an if check and say if this is the case, also just abort. But you can't contest twice. Sorry. So yeah, so we have this here. So now when I get through, these are bed functions. So actually, it needs to actually check for a particular condition now, and that condition is if the total number, the new number of contestants, the total number of contestants is equal to the maximum number of contestants. So I'll put here. So I have to actually check that now. I'll say if new number of contestants is greater than or equal to state dot maximum number. Yeah, great. So I'll create a particular function. So in this particular case, what we're simply want to do is just announce the winners. So announce underscore winners. This is a function we've not yet created. So let's create that down here. Good. So this would also be a stateful variable function. Now it's not going to be an empty point now. And yeah, function name. As for winners, then it's going to be equal to this. So if let's say the person that's actually calling the contract at present time is probably the last person we want to actually call the contract, we should specify that through the maximum amount of maximum amount of contestants that we're actually expecting. So what we can do is we'll step into this particular function which we announce the winners. So first of all, I said that earlier that the winning number will change. Let's I'll just put a colon here. We'll change during block underscore height. Then mode. Now there will be states dot what's maximum wager again? Maximum number of wager. State dot minimum underscore number. Sorry, minimum underscore number. So that would. No. Okay, maximum. I want to be sure that was maximum underscore number. I already tried that time. Good. So yeah, state dot maximum underscore number. Great. So now this is how the win number is actually decided. It chooses the current block height and performs the modulo operation on the winning number or the particular maximum winning number that we actually specified earlier on. So yeah, so great. So after this, now we're going to run a particular function. Now we'll use this dot filter. Now use a function. An inbuilt list particular function again. We're using the list library we actually imported earlier. So now we'll say let's okay, great. So let's list of winners. Let's call them list underscore winners is equal to list dot filter. So what the filter function actually does is that it takes in a particular predicate too and the list item we're actually filtering through. And what happens is that it's going to return each particular item in that particular list as a new list that actually fulfills that particular predicate or that particular condition. So we can just say a now, and let's do this now. A dot number equal to winning underscore number. So great. So now next step is to pass our list learner states dot list underscore contestant. So all we want to do is that we'll check for each particular contestant if the number is specified is equal to this winning underscore number. What we want to actually do here too is we want to put our winning number, states winning underscore number equals winning underscore number. Now don't forget we actually put a colon here so that just in case we are using some because I omitted that here now. So yeah, so here we are. The list of winners to be equal to the filtering of this list for list of winners. So we can now check now. We can come in now. We can say let's underscore of underscore winners be equal to list dot length. So we can use a particular input function on our list library again. Winners dot length. Good. And yeah, list underscore for underscore winners. So by doing this, like this underscore of underscore winners. By doing we just filtered our winners list now. And yeah, sorry, don't mind me putting a semicolon there. That's from Java. So this dot length. So this return the total number of winners actually. So I could check and say, okay, if number underscore of underscore winners, if it is less than 0, so if it is equal to 0, is equal to 0, that means nobody actually won the lottery. So all what I want to do is we'll actually just call the function chain.spend. Now what we want to do in this particular case is to give the particular money now, that money everybody has added to the contract, to the we actually want to give the particular money to the address that deployed the contract. And yeah, we did not actually save that, so we need to actually save that now. So let me come here. I'll come up to our state now. Now say deployer underscore address equal to colon address. We need to make it equal to the address of the person calling the function. So equal to call.colon. So since we've added that here now, we can surely access it here now. Chain.spend. Now chain.spend takes in two things actually. The first is actually the address of the person you are actually sending a particular amount to, and the next is the total amount you are sending to that particular person. So I'll come in and I'll say chain.spend. It's deployer underscore address. Now the thing is, we need to actually get the total amount added to the contract by all these contestants. A particular way to do that will be to filter or to look through all the lists. So we can use list.find now, something similar, then actually add all the amounts of the contestants together. But a much more simpler way to do that is for us to come back to our state again too. So right here, I can add total, let's go tokens, let's go added, let's go by contestants. The file is going to be of type int. Then great. So when I come here, because I've added it, I need to actually give it an initial value here now. So obviously, initial value will have to be 0. So I'll say it's going to be equal to 0. Great. So yeah. So right here too, I'll need to actually update it now in our vet function. So I would say let's new this. Yeah, so let me just append the new at the front, or let me do this. Let me put a colon at the front here. That this can lead to errors if one is not careful. So this will be equal to state dot total underscore tokens, then plus call dot value. So yeah, so what I'll do now is to actually just add this to this particular place. So the IT is now saying total underscore tokens, yeah, equal to total. Then I'll put this in. That makes sense. Yeah. So anyway, here now. Sorry. I want to make sure you can see the whole thing here. Yeah, it's getting much. So chain.spend, then right here now we can now access the total amount in the contract now. State dot total, yeah, great. So we have this here now. So in an else case now, if let's say this is not actually the case, that is they actually winners now in this case now. Else, what we want to do now is, I think we should just create a function. Let's call it transfer underscore tokens underscore to underscore contestants. Great. So yeah, we have it, and we may have created this particular function now. So I need to create that now. So great. So let's come here, and I'll make the function, and I'll call it transfer underscore tokens to contestants. Great. and make it equal to this. So yeah, so this particular function is going to actually be payable now. Payable, great, because it's going to actually transfer money to the contestant. So what we are going to do is we would actually have to look through the list of there's still a lot of stuff to do here. So we have a list of winners here. What we're going to do is we'll look through this list of winners, then we'll calculate the value for each one of them, and we would then send their money to them. So what we're going to use a particular method to calculate this. Method we're using is we'll look at the amount added by each winner to the contract. We will divide it by total amount added by the winners. Then we'll multiply it by total of the amount of tokens added to the contract by all contestants. So the amount added by a winner multiplied by the total amount of tokens in the contract, then divided by total amount of tokens added to the contract by the winners itself. That's actually what we would actually be using. So what would happen now is that we would have to use a for each. So I'll come in now and I would say this dot for each. This dot for each. So let's start here actually. This dot for each. So what the list for each will do is that it would look through all the items in a particular list. Is an inbuilt list function. So what would happen is that it will take in the list it's going to actually look through. Then it's going to actually take in a second argument as a function it will call for each item in the list. So what we'll do is this now. We'll say dot for each, then list underscore winner, so the list of winners. Then we'll pass in a particular function that is going to call now. So we'll say record underscore total underscore tokens total record underscore total total underscore winner. Yeah, sorry. So now let's create this particular function. I've made created this too. Have this to call and so and now be this then equal to then this particular function will be stateful because it's going to actually record the amount of tokens added by each winner to the contract. So we need to actually create this again in our state too. So for the total underscore winner. Sorry. Underscore tokens. Then to be of type int. Great. So yeah, let's give them value of 0 here too. Make it equal to 0. Great. So yeah, let's put a comma here too. Let's put a comma here. So what this particular function will do is that it's going to actually receive when the list for each function calls each particular function for each particular list item, it will actually receive that particular item. So let's just make it contestant now with the colon now. Then let's say let's value is equal to contestant dot state dot total underscore winner tokens plus contestants. We'll get now that we stored the amount added by a contestant to the contract using contestant dot using the value keyword earlier, value key actually. So now we'll just put now states. Then this total underscore tokens equal to value now. Wait. So we'll do this, we add these two together, then we actually save it in state. So now for each particular winner, now this particular function will be called. Now, lastly, now we need to create this will be our last function now. This dot for our last this thing is dot for each. Then it would be list underscore underscore. Now this particular line of code that would transfer the money to each particular person, each particular winner. This. Wait. So let's now take control this particular function too. Sorry. Yeah, so now just for each. Right. So yeah, so we need to create this particular function, and this is what we actually have. So it will receive a contestant soon, just like the other function, contestant. So now what will happen here is we'll say let value to spend now. Let's make value underscore to underscore spend. Let it be equal to contestants with value, then multiplied by states, the total divided by contestants. Yeah, great. And divided by states, the total underscore winner underscore tokens. Great. So we'll now send this out now. Chain.spend to the contestant's address and access by contestants user with then comma the amount actually sent in now should now be value underscore to underscore spent. Great. Okay, our I made a mistake here. Contestants. Sorry. Contestants. Sorry, contestants. Yeah, great. So we have this now. So yeah, so I think we are done with most of the code for this. Let me refresh this page actually, so that I can make sure. Okay, great. So send there's an error at line 71. So let's check that out. Underscore winner underscore tokens underscore tokens modifier M71 modifier. Okay, sorry, I got to write the word function here. The function. So also this should be for each. For each thing. Great. So lastly, we there's a small typo error here. Great. So let me also create a particular function that allows to get the winning number entry points. Then I will say is equal to states dot winning underscore number. Great. So does not have field value, field dot value. Okay. Equal underscore. This one I'm having an error at line 67. It's telling me record type contestant does not have. So let's see. Okay, yeah, seriously, that was a mistake. What CS actually amount? So let me control digits. I use this any other where. Okay, I use it 2 times. So this should be amount, and this should also be amount. Great. So let's see again now. Function chain dot spend of non-stateful function. Non-stateful function. This function should be stateful. Yeah, great. Then test out the deploy. Okay, great. So let's come in now. Let's specify 1A token. And let's bet on 5. Let's bet on 1 now. Okay, great. So it was debited, yeah. Great. So let's use another account now. 112.998 tokens. Let's specify 1, 2. Then let's bet on 1, 2 again too. So let's see. $0.998 tokens, great. But that is not what we actually want. Let's see. Let's get the winning number. Okay, so we cannot call this currently because of this. Great. So if you get number, I should actually return 1, which is correct. So with this, we've been able to develop our lottery application, although I have to comment 3 lines of code out for this to actually work properly. I've actually written the code previously, which I would actually share a link to where a particular pull request that contains the code or a particular record that contains the code later. So that brings us to the end of this particular session. Please, if you have questions, do let me know. Thank you.
Thank you so much, Jesulonimi. That was quite explanatory. Thank you. If you want to learn more about it, Jesulonimi, you said you've done this before, and where can you send a link to the chat box so that everybody can see it and just go to it.
Okay, I would actually create a repo now and actually do that. So
Okay, thank you very much.